Thanks, folks, for joining. Those who are joined till now, and I hope so. You are all doing awesome till now. And yeah, to talking about today's speakers and one of my friend from community as usual. So Tanay Mehta is one of my friend, and yeah, he's a great well, he's great doing in basically in machine learning. By the way, he's some kind of one of my inspiration. Even though I'm not started with the Kaggle stuff in a more regular way, but he's a Kaggle Grandmaster, and those who know what is Grandmaster means, so you know. So he's an incoming MSDS student at the University of Bath. Yeah, yeah.
Okay, guys. So first of all, thanks a lot, Kartikeya, for having me, and thanks a lot, you guys. दिन में आप लोग सोने की बजाय आपने मेरे इस पे आना चूज किया. Really honored. तो the paper that we're discussing today is attention is all you need, and I think इस point पर सबसे pivotal paper जो हो सकता है natural language processing में वो ये है, क्योंकि without this ChatGPT, GPT-3, GPT-4, nothing is possible. Like, this is the very foundation of all these um, big models, all these big transformer models, as I say, right? So this is one of the classic papers. This is why I decided to do this one first. It's the three authors are Ashish, Noam, and Nikki. They're excellent human beings. I've talked to them, and yeah, they're really smart people. So the general gist of the paper is, इसके लिए हमें थोड़ा सा पीछे जाना होगा. We have to go a little back to the time when there was nothing called attention, and the old networks, the old neural networks that were used for text generation, text classification, and all that, they were either RNNs or LSTMs. So if you don't know what that is, let me just quickly show you. So in an RNN, let's say you have some sentence, right? The cat is cute, right? So in that you encode every word to give a number to every word. इसकी बहुत सारी strategies होती है, but let's say कि हमने इसको दिया 0, 1, 2 and 3, right? So ये vector हो गया 4 numbers का, and then we pass this vector to our model, right? So how we do it is we pass this all these to the model, and we want to we want to make a network, a neural network that will find out ki is this a positive sentence or is this a negative sentence. So sentiment classification. So this is a general overview of RNN. There were one neuron, two neuron, three neuron, and जितने भी neurons हैं, they were like that. ये सारा data अंदर जाता, ठीक है, and this is like there's also a zeroth neuron. This is first, second, third, and fourth. And यहाँ से we got an output. So we will not use this output in sentiment classification. तो इससे basically for every neuron there are two outputs. There is this one जो हम इस केस में यूज नहीं करते हैं. There is this one जो second neuron में जाता है. So we are only focused on this, right? So this is H1, H2, H3. Okay, so how it works is कि at the end when our sentence has ended we will have some H n neuron, right? We don't know क्या है वो, and that output will be what the sentiment. And this is very oversimplification, by the way. I know it's not totally correct, but this is like an over 50,000 feet view. So this output will be sent through another layer of a neural network, and that will give us the right result. Ki is this either 1 or a 0? So 1 means ki negative sentiment here, and 1 is positive sentiment. So if you see this closely, you will see कि ये sequential है, in that sense कि at one time only one word is passed through the network, right? So the cat is cute, one word at a time. The idea was कि this is very bad because if you have a very large sentence, जो पहले के words हैं, like let's say बहुत बड़ा, let's say this, we have this sentence, right? The dominant से लेकर के decoder तक. तो डोमिनेंट पहले द पास होगा, फिर डोमिनेंट होगा, सीक्वेंस होगा, एंड सो ऑन एंड सो फोर्थ. बाय द टाइम वी रीच इनकोडर एंड डिकोडर, इन वर्ड्स की जो इन वर्ड्स का जो कनेक्शन है पहले वाले इससे. सो फॉर एग्जांपल डोमिनेंट का जो कनेक्शन है इनकोडर से, राइट, डोमिनेंट सीक्वेंस इंक्लूड इनकोडर, तो वो लॉस्ट हो जाएगा क्योंकि हर वर्ड एक एक करके नेटवर्क से पास हो रहा है. तो इट विल बी पासिंग थ्रू सो मेनी कि जो 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 localized information है वो पास नहीं हो पाएगी, and it will get lost. So this is why जो पुराने models थे, this is RNN, LSTM, JRU, they were very bad at long generation. तो अगर आपको text generate करना है, they were very terrible at it if you want to generate a lot of text. क्योंकि जितना ज़्यादा आपका टेक्स्ट बढ़ता जाएगा, जितनी ज़्यादा उसकी साइज़ बढ़ती जाएगी, उतनी ही कम इन्फॉर्मेशन उसको होगी कि पहले क्या आया था, राइट? क्योंकि आप एंड ऑफ द डे आपके पास ओनली ये HN वेक्टर ना, एक वेक्टर है जो बता रहा है। तो दिस इज़ व्हाई this was like not good, and this is why it was not working good. This is why NLP in the first years were very lagged behind, right? So then came attention. So let me just basically explain attention in very simple terms. ठीक है? तो let's say हमारे पास ये sentence है, ठीक है? The dominant wait, yeah, the dominant sequence transduction models are based on complex recurrent or CNN networks that include an encoder and a decoder. Let's just say हमारे पास ये कोई भी sentence है. Attention ये बोलता है, and attention is very intuitive. It says कि you have to pay attention to the words that are important in a text or in this sentence, for example. So in this case, dominant sequence transduction models is an important thing, encoder and decoder is important, and complex recurrent or CNN networks is important. तो जिस तरह से हम पढ़ते वक्त सिर्फ important चीज़ों पे ध्यान देते हैं और बाकी चीज़ें, जैसे for example the हो गया, we ignored the, right? We ignored R, we ignored base, because we kind of know these are stop words. They don't have any value in themselves akele, right? So attention is using this very basic principle to give more preference to the words that are um to the words that are more important for the context, and not give preference to the words that are not important for the context. So now that you know how attention works, let me quickly go over the paper. Okay, so we'll start from the bottom. So this is introduction and all. If you guys want to give it a read, you can, but this is exactly explaining that जो मैंने अभी समझाया recurrent neural network से related. This is just that जो I explained. So okay, let's come to model architecture, right? So I'm assuming ki you guys have some idea, like you guys are a little known towards what neural networks are, RNNs are, LSTMs are, because these are very basic fundamental concepts in machine learning. Like every courses teach them. If you don't worry, you can learn it after this, because ऑनेस्टली ये वाला जो पेपर डिस्कशन है, इसमें इतनी ज़्यादा पुरानी नॉलेज, मतलब RNN LSTM स्पेशली बहुत ज़्यादा यूज़ नहीं होंगे. मैंने अभी बता दिया, और आई थिंक मैं एंड में एक बार मेंशन करूंगा. उसके अलावा बीच में ज़्यादा रोल है नहीं इनका. तो so now we get to this part. So before we start, let me explain in this paper ka terms how attention works, right? So the first step in any machine learning model on how you do it is what we call tokenizing the data, right? तो जैसे ये 3 वर्ड हो गए, generated symbol as additional, 4 words हो गए. आप ये वर्ड्स स्ट्रिंग्स हैं, राइट? पाइथन में आप इनको किसी मॉडल के अंदर पास नहीं कर सकते. यू कांट पास देम इन अ मॉडल, and the reason is because model doesn't understand strings. ठीक है? So for a model, generated word has no meaning. It has a meaning for G, it has a meaning for E, N, and so on, but it doesn't understand what generated means. It has no contextual information for the word. So a situation like that is we tokenize these words. Now there are other things called word embeddings and all that, and they're kind of they extend upon it. But the more important thing that you need to care about is tokenization. So what tokenization does is, let's say I have जो मैंने अभी I think start में किया भी था कि it was the cat is cute, right? So I have this sentence, and so what I was saying is कि for every word in this we assign a unique number or whatever number. So for bigger models there are specific places where you calculate these word embeddings, and you calculate, you tokenize the words based on their similarity. We are not getting into that, but a very short brief intro is, let's say I have 2 words. I have a word, I have coffee, and I have another word tea, and then I have a third word which is I don't know, orange. So there are these 3 words. So in a very nutshell manner, how this works is, let's say I have a vector space. It can be whatever dimensional. I'm saying 3-dimensional vector space. So in 3-dimensional vector space, I will have one vector which will be coffee, right? It will, the vectors direction and magnitude will basically represent coffee. The other vector will be tea, and it will be kind of close to coffee because coffee and tea are more or less not similar, but they are in the same category. And the vector orange will be way far, because orange, tea, and coffee are not similar. Like coffee and tea are in same category, orange is way far, right? So these positions in this n dimensional vector space they basically tell us how important like how important like each and every word is. So the relative position of these word vectors, they tell us how similar a word is to another one, right? So for example, let's say coffee को मैं represent करता हूँ -2 से. There is no reason मैंने ऐसे random word choose कर लिया, तो मैं टी को represent करूंगा maybe -1.5 से. बट इन दिस केस मैं ऑरेंज को रिप्रेजेंट करूंगा किसी टोटली डिफरेंट नंबर से, -86.7, because it's not similar. And don't look at, I'm using minus sign to tell you ki this is not all, positive numbers. They can be anything. These are learned like a neural network learns. These are also learned. Okay. So once that is done, let's so now that you know how this works, but even in this case हम सिर्फ basic example पे focus करेंगे 0 1 2 3 basic encoding, right? So when you pass these numbers, so let's say you have a sentence and you encoded it, and let's say uh, you know it becomes a vector. So मेरे पास कोई भी xyz vector है, उसके अंदर ये सारे numbers हैं. These each and every one of these can be a word or a subword. So let's say 5, 65, 81, 91, or not minus 102, right? So these are some encoded representation of some dictionary of some sentence, some string. Okay. So what do I mean by attention in this context is, um, how do I pay attention to this? Like, how RNN works कि मैं एक एक को pass करूँगा RNN modules and then I'll get the output, और translation करना है तो translation होगा encoder decoder से, वरना I'll get the sentiment after a neural network. In this case, let's say I have this sentence, right? And I have another sentence here. Matlab, this is the same sentence, but if you see, this is a column vector and this one is a row vector. So this is the same sentence, and what I'll do is, let me just quickly write this one, 91 and 102. So what I'll do is I'll multiply this sentence, this encoded sentence, with itself. Okay. So if you have studied thoda sa matrix multiplication, you will know ki how do we multiply a sentence with it, or how do we multiply two vectors or two matrices, is using dot product, right? So let's call this sentence S, big S, and this is also S, but if you see, this is S transpose, right? Because we are transposing it, so we can't multiply S dot S. This is not possible if both of them are same. So अगर आपको कोई दो same size के vectors multiply करने हैं, दो same size के matrices multiply करने हैं, तो you can't do that normally. You have to transpose one of them. So in order to do the dot product, you have to do S dot product S transpose. So this is the very core concept of attention, is that you multiply this, right? So in this, every element will be multiplied by every other element, right? I hope you get the picture. And other than a dot product, in dot product only, for like also called Hadamard product, in that one element will be multiplied by the corresponding element and not all. In dot sorry, that was a different one. Okay, I was confused. That was a scalar product. So in dot, every element of one vector will be multiplied by every element of the other vector, right? So this way you will have a very big matrices of multiplication by itself. Now you might be thinking, iski kya significance hai? So the significance is कि when you multiply two vectors, you kind of calculate, or not kind of, but you calculate the similarity of two vectors, right? So, and this is a very core concept. There are many other ways to calculate similarity. You can do cosine similarity, you can do any type of similarity, but when you multiply two vectors, so let's say you have this one vector and you have this two vector. So this thing, so when you multiply, you kind of calculate its similarity. So the product of these two, dot product of these two vectors, will tell you, will give you a similarity matrix. I also like to call it a weight matrix, and you will know why later on. So the result of this whole operation will give you a big similarity matrix. It will show the similarity of every word to itself and all other words. So for example, the cat is nice ke andar, if I do this and I multiply it, I'm not going to do actual multiplication, but if I do this, it's going to like do all the sorts of multiplication. It will return this whole matrix जहाँ पे the की similarity cat is cute से होगी, cat की similarity the is cute से होगी, is की होगी the cat cute से, and so on and so forth, right? So this will be calculated like that, and this will be calculated like that, and so on for every word. So when you do this, you are calculating relative similarities of everything to itself, right? And now later on you will understand the significance of it. So this is the core of attention, is that when you do dot product of every element with every other element, you get how similar that element is to all the other elements, right? So now let's go to the actual architecture. This is the architecture of the model. So let me just erase that one. Right. So there are two general modules in this transformer. This is called a transformer, by the way. This module, this one that you are seeing right now, this guy, it's called an encoder, and this guy is called a decoder, right? So, and it's very easy to understand what each module does. So, encoder का job है लैंग्वेज के सेमांटिक्स को लर्न करना, और डिकोडर का जॉब है आगे की कैलकुलेशन और कंप्यूटेशन करके आउटपुट देना, वट एवर इट मे बी. इफ यू वांट टू जनरेट text, decoder will do it. If you want to do classification, decoder will do it. If you want to do Q&A, summarization, whatever, decoder is your man, right? But for learning how the language is, it's encoder, right? So in fact, if you might have heard of two different types of like two अलग अलग दो अलग अलग तरह के models के बारे में. There is one called BERT, which is very well known, and of course your old GPT. So now there will be a lot of similarities. You will start understanding. BERT is actually an encoder only model, जिसके टॉप पर एक एक्स्ट्रा लेयर लगी हुई है. And GPT is a decoder only model. In fact, GPT, Chat GPT, GPT 3.5, every other unsupervised large language model or unsupervised language model is a decoder only model, जो जिसका काम सिर्फ टेक्स्ट प्रेडिक्ट करना है. इन मॉडल्स का एक और नाम है which you will find a lot useful is auto regressive models, right? And the reason they are called auto regressive is because let's say मैंने उसको एक टेक्स्ट दिया द, ठीक है, और उस मॉडल ने, मतलब यहाँ मैंने द दिया, आई पास द, and it went through, it went through. I know this is not the GPT paper that is coming, but I'm just giving a quick overview so you guys can understand well. And it generates the next word to be boy. Okay, so now we have this new output, the boy. So what autoregressive does is that ki every time you want to generate the next word, you give all the last generations to it. So first मैंने the दिया तो मुझे boy मिला, अब मैं the boy दूंगा तो मुझे मिलेगा is, और उसके बाद मुझे next generate करना है तो मैं the boy is दूंगा तो मुझे next मिलेगा, and so on and so forth. So this is what we mean by autoregressive. This is the core concept of how GPT works, but we'll get there later. Right now, let's focus on the transformer part, right? So this part, the encoder model, the job of this model is to learn what English is. So let's say मैंने इस model, ये जो पूरा model है transformer, let's say I trained this for 50 epochs on English language data, right? The job of this model is then going to be this part, sorry, the encoder part is then going to be to learn the semantics of English language, right? In English language, what prefixes are, what suffixes are, what like what are conjunctions, the core of English language, how English language works in itself. So encoders main job is to learn and understand whatever language, whatever text it is given. Decoder's job, as I told you, is to predict, right? So now that you know the different roles and all that, let me just as I quickly go over both of them. So let me start talking about the model, and I'm not going to read through this because I'm explaining whatever there is written here. Keep in mind, when there is n cross, it means that this thing, this little block, is multiplied n times. So there are n of these blocks stacked on top of each other. Generally, you will see the n is 6 here. So for example, n is 6, so there are 6 identical blocks. So 6 of these on top of each other, and the final output is then passing through this part, right? So also there is another thing to note here, is that the output of the encoder passes to the decoder. This is where the connection happens. This is where the knowledge that the model learned in the encoder, the knowledge of English language, is transferred to the decoder, where it will use that to give it the output, right? So okay, so we know the basics. We know the general basics of how a machine learning model works, right? You a supervised ML model. So you give it some data. Let's say you give it I don't know, 500 samples of data, 500 strings text, and you have 500 different classes. So let's say you want to do you want to do binary classification ki if this text is 1 means it's positive and 0 means it's negative, you know, toxic sentiment classification, whatever, right? So there are 500 samples and 500 corresponding targets, right? So you have samples and targets. So how this works is how we will pass our samples and targets to the model one by one, right? एक एक करके will pass, or in batches will pass, whatever the strategy is, we'll pass them one by one. So every time the the sample, the input data is passed to the encoder, and at the same time the output is passed. Actually it's a little more complicated than that, but this is how the actually the output is not passed here in the sense it will be passed, like it will be calculated here, but yeah, so we'll pass the text through both of them. Okay, I think I confused a lot here. So in sense that we will give the same output to both of the sides, but the as you can see यहाँ पे output पे लिखा है shifted right. So what shifted right means is that we will not give the entire sentence to the model. So as I told you, it's auto-regressive, right? The architecture कि internally क्या हो रहा है, but the job of encoder is to learn the semantics of language. मतलब there are certain rules of language, right? There are rules of English language, whatever there are कि XYZ, punctuation and all that. And so this is what encoder will learn, and the information will be transferred here to the decoder. So this multi-head attention, it's actually called cross attention because it's using information from two different sources, one from the encoder and one from the old decoder output. And the job of the decoder is to actually generate data, right? It's to generate text. Let's say GPT example everyone knows, it's to generate text. So this is in general it. So if you अगर आपको कुछ भी समझ नहीं आ रहा है and you have no idea, okay, just know one very important thing. Encoder will learn about the data, the structure of the data, the text जिस पे भी आपने train किया है, and so its job will be to learning the language, right? Learning the language, and the job of the decoder will be to generating, or you know, generating the output, whatever it is. Let's say आपको you are doing fill in the blanks. There is a very big problem called fill in the blanks or data summarization कि आपको बहुत सारा एक ऐसे दिया हुआ है and you have to summarize that, your model has to summarize that. So this guy will learn the essay, this guy will be outputting the summary through the output probabilities. तो अब मैं in depth जाता हूँ कि what each and every module is doing. Let's start from the beginning. So I think I covered about the input embeddings, right? We convert that string data, we convert the input data to numerical representation. We tokenize it or whatever we do. So this will get that input embedding. So that is the same in both of them, embedding part. And then comes positional encoding. Okay, so positional encoding मैं समझाता हूँ. So how positional encoding works, and यहाँ पे ये एक wave बनी हुई है. So we all know about sine wave, right? This is a sine wave. So I don't know. Let's. So this is a sine wave, okay, and then we'll have another sine wave which is like this, जिसमें ज़्यादा crest and rows हैं, and there is another sine wave जिसमें काफ़ी ज़्यादा crest and rows हैं, right? So let's say I have some word, I have हमारा old example, right, which is the cat is cute, right? So we assign a number to them through input embedding part. So 0, 1, 2, 3. Okay. So positional encoding का crux ये है कि we encode the value, or we assign values to the position so that we know what comes before and what comes after, right? In encoding, it's to preserve the positional information, the localized information of the of the model of the data, sorry, right? So let me choose some good color. Yes. So in this case, let's say 0 1 2 3. तो मैंने 0 यहाँ पे किया, 1 यहाँ पे किया, 2 यहाँ पे किया, 3 यहाँ पे किया, राइट? सो मैंने वो जो अपना डेटा है उसे लिया और एक साइन वेव के ऊपर मैप कर दिया. दिस इज प्योरली फॉर एक्सप्लेनेशन पर्पसेज. नीचे जाके इसका एक पूरा फंक्शन दे रखा है, बट जस्ट टू एक्सप्लेन यू गाइज. सो दिस इज 0 1 2 3. ये जो सारे वर्ड्स हैं मैंने यहाँ मैप कर दिए, राइट? सो now there are 0 1 2 and 3. Now let's say I want to find out the location of 2, right? So this is less na, kyunki I'm still on the same sine wave, so it's less information for me to understand what exactly is means, because is what 2 is, right? So this is okay. So now I will see where is mapped. So is, you can see, is mapped in the bottom part of the sine wave. So top, like mid, top, bottom, and top. And so now I have a more higher idea ki where exactly is the word is comes in this entire picture. Okay, and then I'll see another mapping representation, and it will make it even clear, right? So don't see the toes and crest of the wave. If you don't understand any of this, just know that positional encoding tells our model the locational information, where the text, where is the text located inside the model, inside the data set, what is the significance. So it basically encodes the positional values, right? What comes before, what comes after. So that is added to the input embedding. So it's not transformed. Input embedding को हम लोग positional encoding में transform नहीं करते. It's actually added, and then we pass it to the model. Okay, so what does the model do? So now you'll see a new word called multi-headed attention, right? तो मैंने आपको अब तक attention एक बहुत simple example से समझाया था. Let me explain it to you in a more formal sense, जैसा इस paper में दे रखा है. So there are two types of attention. There is one, I mean, it's kind of the same. So there is scaled attention, scaled dot product attention, and multi-headed attention. So जब हम बहुत सारे scaled attention को लेकर के एक साथ जोड़ते हैं तो we get multi-headed attention. So every one of these heads, these are called heads, ये purple वाला, every one of these heads is basically this is all of these heads, and we have h number of these heads एक साथ parallel में, right? So now you will be seeing these v q k q. So let me explain. This is, I think I explained, right, कि हमारे पास एक sentence है और हमें उसका dot product करना है, तो we do s dot s transpose t, right? So s dot s transpose t मतलब we are multiplying the same vector by itself to find the similarity, right? So this is exactly that. So यहाँ पे आपको तीन words मिलेंगे: query, key, and v, which is the value, right? So what these words mean is there are like different types of attention, but right now all of these three are the same thing, which is our current sample. So for example, हमारा वो example था जिसमें 0 1 2 3, right? We had these four words. So query key value, all three is the same thing. Since I mentioned कि हम query and key sentence को खुद से multiply करेंगे, you can actually see something similar. So अगर आपने DBMS पढ़ी है, and if you want a DBMS based outlook of that, you can say कि I have some query and I run it through the model, and I have a query and I run it through the model, so I get a key, right? So let's say this is your, and this is not a very right understanding, but you will kind of understand. So you have a query key, I want whatever xyz records. In this, you run it through your database, so then you will get some key, right? You will get some index key. Whatever record you want is located at, I don't know, 102nd position, and using that key you can get the value, right? The exact record. So think of it like the database wala perspective. I think understanding attention, personally, it took me more than 6 months to even understand how exactly this works. So if you don't understand in the first try, don't worry. There are like actually entire papers understanding explaining, but I'll do the best I can. So all you need to understand is key query times key transpose is basically taking a sentence, like the tokenized sentence, and multiplying dot product, doing the dot product with itself, right? So I told you, right, if you do a dot product, you will have a vector which is you will have a vector which is the similarity vector, how similar every sentence is to its, how similar every word is to itself. So once we have this similarity vector, what we can do is we divide it by under root dk. Now in gpt it's a different thing, but under root dk is it's it's a way to scale, right? It's the dimension of keys, so it's a way to scale. So if you know, if you multiply दो बड़ी matrices with itself, the output is very large, right? And it can create numerical instability while training. So you do under root dk so that it's scaled down. That's one way to think of it. The other way is ki you can multiply divide by number of heads, but the easier way is कि under root dk square root dk से multiply करने पे the we scale the numbers down so that they are in a range जहाँ पे numerical instability create now, and then we create softmax of this. So if you don't know what softmax is, let's say I have some vector x, right? And it is x1, x2, so on, xn. What softmax will do, or let's say हर vector की कोई value, let's say this is 4, 6, यहाँ पे कोई है जो 82 है, ये है -5, ठीक है. सो इट इज अ वेक्टर ऑफ मल्टीपल वैल्यूज. यू कैन थिंक कि जो हमारा टोकनाइज डेटा है ये वो है, ठीक है. सो सॉफ्ट मैक्स का काम ये है कि वो एक वेक्टर को लेगा और इट विल स्केल द एंटायर वेक्टर सो दैट इट्स अ प्रोबेबिलिटी डिस्ट्रीब्यूशन, ठीक है. सो द फॉर्मूला इज, if I remember correctly, it's e to the xi divided by summation of n I is equals to 1 e to the xi. I'm not sure, maybe मैं गलत हो सकता हूँ, but the core idea of softmax is कि you know the basic foundation, right? कि probabilities in a single event shall all sum to 1, right? सारी probabilities 1 होनी चाहिए. तो let's say मेरे पास एक वेक्टर है जिसमें 4 वैल्यूज हैं, तो और मैंने उस पर softmax अप्लाई किया, so that when I applied softmax to this, now the vector is transformed into bunch of probabilities. So let's say मेरे पास एक वैल्यू थी x1, x2, x3 and x4, right? x1 एक बहुत ही बड़ी वैल्यू थी, ठीक है. x2 एक like there was just some value, x3 was also some value and x4 was a very very small value. So जब मैंने इस पे softmax अप्लाई किया, तो after this will be transformed into vectors. So let's say अब x1 की वैल्यू हो गई 0.65, x2 की वैल्यू हो गई आई डोंट नो 0.2, इसकी वैल्यू हो गई 0.657585 या 0.1 एंड ये हो गई 0.05. सो इफ यू सम दिस अप, आई थिंक दिस सम्स अप टू 1, आई एम नॉट श्योर, राइट? सो नाउ ये जो x1 जो बहुत बड़ी वैल्यू थी उसको एक प्रोबेबिलिटी एक मिल गई, x2 को भी मिल गई. x2 और x3 काइंड ऑफ सिमिलर थे तो दे आर सिमिलर, एंड x4 जो बहुत छोटी वैल्यू थी इट गेट्स अ वेरी स्मॉल वैल्यू. सो सॉफ्टमैक्स का काम कोई भी वेक्टर को लेना है और उसको एक प्रोबेबिलिटी डिस्ट्रीब्यूशन में क्रिएट कर देना है, right? And I think you can see where this is coming from, because at the end we want to predict like get probabilities, but this will, so softmax के अंदर आप कोई भी वेक्टर डालोगे तो it will basically make it a probability distribution, right? So now you have this. If I think some of you might have guessed this, but you अगर आप ये internal element, let me just clean this a bit, अगर आप ये internal element लोगे, this one, this will get you a vector of similarities, right? कितना सिमिलर एक वर्ड है खुद दूसरे वर्ड से, राइट? और what attention, how much attention should we pay to one word, like how much attention is every word worth, ठीक है? These are also called weights, by the way. Softmax will convert this whole thing, we use a different color. Softmax will convert this whole thing into weighted probabilities, okay? Weighted probabilities, and then we do a dot product with v. Now I think I told you कि यहाँ पे query and key same है. v is actually also the same sentence, right? So ये जो s था ना query and key जिनसे हमने multiply किया, v is also same values. In this case there is other attention called cross attention, जहाँ पे value different sentence हो सकता है, but यहाँ पे it's the same. So now you have a v, so you have weighted probabilities, right? So you have a matrix like this, and it, if you think about it, it actually looks like कि हमें किस वर्ड को कितनी अटेंशन देनी है. So this is the weighted probabilities wp, and the v, the original sentence is, let's say, I don't know, 0 1 2 3, the same, right? So now if you take a look here, ये सारी corresponding values है, right? Each of these is corresponding. So zero को सबसे ज़्यादा probability मिली. By the way, this is just to explain, ये exact sentence नहीं है क्योंकि the cat is cute के अंदर the की कोई value नहीं है. I think cat और cute की probabilities होनी चाहिए ये, but let's assume यही है. तो 0 and 1 को काफ़ी probabilities मिली. So when you do this whole operation and when you multiply it by v, you kind of यहाँ पे you're calculating weighted probabilities कि which word is more important, and then you multiply it by v to get the that actual important word. So think of it, if it doesn't make sense to you, think of it as a get an update operation in a database. Ki you find the indexes and then you get the corresponding values. Jaisa I told you, right, ki you have 100 in second index and then you get the value corresponding. I personally think of it like that. So this is basically all of attention. You take a sentence, you make it numerical, you multiply it with it, you do a dot product with itself to find what the to find the similarity of each word to all the other words, and then you get all the like you pay more attention to the important words and less attention to the non-important words. So this is exactly what attention is. I hope लोगों को समझ आए. If anyone has any doubt, please guys post it. Let's just like wait for 5 minutes and let's see if anyone has any doubt, क्योंकि इसके अलावा it's just architecture, there is nothing more here.
For now, I guess there is no question. Let me check. I guess there's someone asked something. Can we compare it with a neural network in which we multiply the weights and inputs? Like I guess Mr. Random ने पूछा है.
I um I mean see this is a very funny thing क्योंकि this type of attention is called explicit attention. I guess मैं names mess up नहीं कर रहा हूँ, ठीक है, जहाँ पे हम explicitly attention use कर रहे हैं. You know, the funny thing is that a neural network or a convolutional neural network, let's say, also has attention. It's called implicit attention. So all neural networks by the get-go uses attention, but this is a more explicit form in the sense ki see, in a neural network we are not doing, like we are kind of doing inter-data thing, but we are not using so let's say हम एक tabular data का neural network है, right? So we have some tabular data with some rows and some columns. In that the the relation of this xyz column and this other column, there may be a relation, but we are not really doing that explicitly. Here we are doing it. So in principle you are kind of right, this is more or less the same thing, but this is more explicit attention, and we do this क्योंकि language data में हमें अगर लोकलाइज्ड इन्फॉर्मेशन प्रिजर्व करनी है, जो मैंने आरएनएन के एग्जांपल में समझाया था कि बहुत पहले की इन्फॉर्मेशन प्रिजर्व ही नहीं हो रही. अब लेट्स से हमने वापस से वही एग्जांपल लिया, राइट, लेट्स गो बैक टू द सेम एग्जांपल, दिस वन, राइट, यही था हमारा एक्चुअल एग्जांपल जो हमने आरएनएन में लिया था, राइट. इन दिस केस जब हम इस पे अटेंशन अप्लाई करेंगे तो what attention will do is that it will give way more, बहुत ज़्यादा weights देगा वो उन जगहों को जो इस न्यूरल नेटवर्क ने लर्न करा है कि ये इम्पॉर्टेंट है, राइट, थ्रू द लर्निंग प्रोसेस. सो डोमिनेंट सीक्वेंस ट्रांसडक्शन मॉडल्स को ज़्यादा अटेंशन वेट्स मिलेंगे, कॉम्प्लेक्स रिकरेंट कॉन्वोल्यूशनल न्यूरल नेटवर्क्स को ज़्यादा मिलेंगे, इनकोडर को ज़्यादा मिलेगा और डिकोडर को ज़्यादा मिलेगा, ठीक है. दिस वे ये जो डेटा है सिर्फ यही कैरी आउट होगा जब हम डिकोडर में सेंड करेंगे, ना कि ये सारा फालतू का डेटा जैसे द कैरी आउट हो गया, आर कैरी आउट हो गया, इंक्लूड हो गया. दीज आर यूजलेस वर्ड्स. सो दिस इज एक्सप्लिसिट अटेंशन. दिस इज वाई इट वर्क सो वेल, इज बिकॉज ये जो हमारे पास डेटा है उसमें काफ़ी सारे स्टॉप वर्ड्स हैं. अगर आपने बेसिक एनएलपी करी होगी किसी पॉइंट पे, तो देयर वाज दिस टाइम जब पोर्टर, स्टेमर और स्टॉप वर्ड्स फ्रेमवर्क यूज होते थे एनएलटी के, मतलब नॉट फ्रेमवर्क बट मॉड्यूल्स, जहाँ पे आप स्टॉप वर्ड्स को रिमूव कर सकते हो, right? So that's the kind of the same logic because you don't want unnecessary information. So yes, to answer your question, this is kind of the same thing but in a very different context. That is implicit, this is explicit. Yeah, so that's the same thing. After that, अगर आपको ये 3 एरो देखना है तो ये की क्वेरी वैल्यू के, ठीक है. So one part of this will be sent to multi-headed attention. The other part, this is called, people call it residual connection, I call it skip connection. We send a copy of this here. So यहाँ पे मल्टी हेडेड अटेंशन का आउटपुट होगा, हम उसको ऐड करेंगे पुराने एक्चुअल आउटपुट से और उसका नॉर्मलाइजेशन करेंगे, and then we pass it through a feed forward basic neural network. I assume you know what it is. And then we do the same thing. So इफ यू आर वंडरिंग व्हाई दिस आर्किटेक्चर, आपको इसका आंसर एक दूसरे पेपर में मिलेगा विच इज कॉल्ड मेटाफॉर्मर. It's called Metaformer is all you need. It's a very good paper. They actually said कि you don't really need attention to do good. You can do without attention. So if you want to read more, read the Metaformer paper. It's a very good paper. वहाँ पे उन्होंने attention को replace करके max pooling लगा दी and it performed pretty well. Right? Anyways, I'm talking in favor of attention, so I won't go back today. So once we do that for n number of blocks, we send that to here. नाउ यहाँ पे दो डिफरेंट चीज़ें आपको दिख रही है. एक तो ये यहाँ से डेटा इधर क्यों आ रहा है, एंड ये मास्क सेल्फ अटेंशन क्या है. ओके, तो ये मैं जीपीटी के कॉन्टेक्स्ट में समझाता हूँ. इट विल बी ईजियर, राइट. लेट्स से मैंने जीपीटी को बोला कि लेट्स से ये एक आउटपुट है जो मुझे जीपीटी से मिला, तो हाउ डू आई स्टार्ट. ठीक है, आई विल स्टार्ट. तो मुझे ये सब तो दिख नहीं रहा है, यहाँ पे क्या लिखा हुआ है. आई स्टार्ट विद द, सो आई गिव द टू द जीपीटी एंड देन इट विल प्रेडिक्ट द नेक्स्ट word, right? So then it will predict encoder. Oops, it will predict encoder. Then I give the encoder, it will predict is. Then I give the encoder is, it will predict next, and so on, right? Auto regressive model. So when we give this data to this output part, this decoder part, remember this is decoder, right? We don't want our model to see right side में. ठीक है, क्योंकि जब हम प्रेडिक्ट कर रहे हैं तब हमें लेफ्ट साइड की ही इंफॉर्मेशन अवेलेबल है ना, हमें राइट साइड की तो है नहीं, क्योंकि अपेरेंटली दैट इज इन द फ्यूचर, राइट. हमें वो प्रेडिक्ट करनी है, हम वो प्रेडिक्ट कर नहीं रहे हैं. तो इफ वी वांट टू प्रेडिक्ट दैट, like we don't want our model to learn from the right side. So if we want to make our model learn, हमें अगर से टेक्स्ट जनरेट करवाना है फॉर एग्जांपल, we can't let our model see the right side. So what mask will do is that ये पूरा पैराग्राफ तो पास होगा मॉडल के अंदर एज एन इनपुट, बट हम एक सर्टेन वैल्यू के आगे वाला पूरा हिस्सा मास्क कर देंगे. So the model will not actually see, and this is very oversimplification, but the core is the model will actually not see what happens left side of it. And if you want to see a more code based example of this, I actually have one, but this is more of a GPT example. Yes, here it is. So this is what you can see the attention, right? BMM means batch matrix multiplication. So query key transpose, and you do this, and niche you can see masked fill. So this is a function of PyTorch. If you don't understand it, don't worry, I'm just showing a real example. So if you take a look at this, like I will send the repository link later, we are basically masking the right side of the model and filling it with negative infinity, right? So I'm filling जो भी हमें एरिया ध्यान नहीं देना है जिसपे, हम उसको मास्क करके नेगेटिव इन्फिनिटी से फिल कर देंगे. वाई? बिकॉज जब हम इसे सॉफ्ट मैक्स से पास करेंगे, रिमेंबर दिस विल बी पास थ्रू सॉफ्ट मैक्स, राइट? नीचे इक्वेशन में लिखा हुआ है दिस वन. So when you pass negative infinity to softmax, instead of putting it something else, it will make it 0. So we don't want probabilities to be calculated of future values, right? हमने mask कर दिया, but still वो pass तो होगा model से, तो we don't want its probabilities to be 0.1 or 0.2. So negative infinity करने से जब उसे softmax के बाद जब वो softmax से pass होगा, तो it will automatically go back to 0. So that means 0 probabilities. So that our model doesn't learn from the future which it shouldn't learn to predict text, right? So that's the same thing. Then you do the skip connection. Now comes a very interesting part, which is this thing कि यहाँ से कहाँ जा, यहाँ से output कहाँ जा रहा है. So if you remember, I told you about cross attention, कि there is another type of attention where where we get queries and keys. So where we get queries and keys from same source but values from a different, or you can change it however you want. So if you can see, that's I think how it is. If I'm not wrong, this is query, this is key, and the value we are getting from here, right? And if you want a more intuitive understanding कि ये क्यों हो रहा है, तो remember I told you कि encoder का काम language को learn करना है, language के semantics सीखना है, right? And decoder का काम उसके बेस पर predictions करना है. So queries and keys से related जो भी चीज़ें हमने यहाँ पे learn कर ली, so right, and values हमें ये output से मिल रही है. So if you remember, हम weighted probabilities निकालते हैं queries and keys से, and then we multiply it by v to get the words we should pay attention to, right? That's the formula of attention. So if you think about it थोड़ा सा, you will understand कि हम वहाँ से weighted probabilities लेंगे और यहाँ की values से multiply करेंगे, तो हमें current context में अटेंशन मिल जाएगी कि हमें करंट कॉन्टेक्स्ट में किस चीज़ पे ध्यान देना है. इफ इट डजंट मेक सेंस, डोंट वरी अबाउट इट बिकॉज इट्स अ वेरी जनरली अ स्मॉल कॉम्पोनेंट. ठीक है, एंड अनफॉर्चुनेटली वी डोंट हैव टाइम टू इम्प्लीमेंट दिस, क्योंकि अगर मैं इसे इम्प्लीमेंट करता तो आई थिंक आई वुड हैव एक्सप्लेन्ड इट बेटर. बट if it doesn't make sense, don't overthink on it. This is just another part. And then yeah, the same thing, skip connection, you pass it to add norm, you pass one output to feed forward net and another to add norm, and uske baad there are two layers. There is a linear layer and then there is a softmax layer. So again, linear layer is just a bunch of neurons, us pe data ja raha hai, and then they all give data to one, right? And this guy is the softmax layer. So again, I told you softmax takes a bunch of vectors. It takes a vector and it normalizes them to probability. So what is output probability, right? Let's say we are doing text summarization. तो हमने उसे ये पूरा का पूरा paragraph दिया, and we want our model to predict some summary of it. So in essence we are doing text generation, right? क्योंकि हम भले ही कितना भी text generate कर रहे हैं, but it is text generation, right? So so in that case, the output probabilities in every step will be the probability. So again, I think I told you कि there is a vector, right, where each word corresponds to, where each number corresponds to a unique word. So this was cat, this was is, this was cute, right? So then we have these probabilities, and once we, and जो probabilities हमें softmax के बाद मिलेगी, we can use them to get the corresponding word in our vocabulary, right? And I know I'm doing an oversimplification here, but understand this कि output probability से you can get your corresponding words, or you can get whatever corresponding it is. It doesn't have to be output probabilities. So that's all of transformers. Why is it so popular is, apart from attention, one of the key features of transformer is, unlike an LSTM or RNN, it's not sequential. As you can see, इसमें parallel processing काफी ज़्यादा हो रही है. So and also मैंने multi-headed self attention ही बताया. So when you take a lot of these self attention on top of each other, you get multi-headed attention. Why we use multi-headed attention is, let's say कि एक point पे एक scale dot product attention सिर्फ एक स्पेसिफिक चीज पर ध्यान दे सकता है एक सेंटेंस में. थिंक ऑफ इट लाइक दैट. ठीक है, तो मल्टीपल हेड वाले सेल्फ अटेंशन एक पॉइंट पे मल्टीपल चीजों पे ध्यान दे सकते हैं इन अ डेटा, इन अ सेंटेंस. This is why multi-headed self-attention, like there is, these are also hyperparameters by the way. H is a hyperparameter कि कितने heads होने चाहिए versus कितनी blocks होने चाहिए, which you will like learn आगे जा करके, and the output of each of these are concatenated. ठीक है, you can actually see this down below. Yeah, so in multi-headed self-attention, you take output of every head, where every head is the same attention thing that we talked about, and then we multiply it by some weight again, so that we can learn the multi-head ka best possible weights when we do during training. So in this work they have used h equal 8. So important thing is 8 parallel attention layers or heads. Heads are also attention layers, matlab same hi naam hai. So this way, this model is very parallel instead of being sequential. So instead of your data passing one by one, and क्योंकि हमारे GPUs जिन पे ट्रेनिंग होती है, they are really great at parallel processing, really terrible at sequential processing. Not terrible, but it's not just what they are meant for. So in this case, a transformer model like this, where attention is used, in this case it is easily parallelizable on a GPU or on multiple GPUs. And this is why they are so popular, because they are faster to train, more memory efficient, and they use your GPU better, right? This is kind of the reason why once this paper released, uske baad se all these BERT and GPT and all these models started coming up. So this is the key concept of attention. You guys can go ahead and try to read the paper deeply. I just like explained the basic core of the paper. ठीक है, and as you can see मैंने बताया था कि we set it to minus infinity and all that. ये यहाँ पे सब लिखा हुआ है, like whatever I told you. And this is just the feed forward neural network, basic one layer, two layer neural network. So there's nothing in it. इसमें काफी सारे अच्छे notes लिखे हुए हैं. And see, if you can see here, this compares the self attention to recurrent and convolutional neural networks, and it actually shows that there is a lot of improvement in complexity per layer, in how many sequential operations you have, and how many path lengths you can have. So big O notation mein they have done a lot of comparison, and there is a lot of notes on positional encoding with sine wave as well, right? So yeah, you guys can give it a read, but that's about it. Or niche there are notes on how they trained this model. So that's about it. If anyone has any questions, please guys go ahead.
One more question. Can you tell something about master's application journey? Who recommended you and which university you applied?
So for recommendations, it's only professors. If you are if you are like you were a student before, I applied to a lot of universities in multiple countries. So it's like practically not possible to list all of them. But I mean, the whole master's journey, it's a very different topic per se in this regard. But you have good grades, you have good projects, and you know professors well. That's more than enough. That does it. And you have to like focus on other exams as well. But if you want like a single piece of advice, just maintain good GPA. That's what I'll tell you. Ki don't get backs, maintain good GPA. More than enough.
There is
Thanks a lot, and thanks all for patiently listening to this and staying till the end.